Hey there, everybody. It's your co-host with the co-most, Phil Nelson here, OpenCV Director of Content and Creative, welcoming you to OpenCV in Conversation, our brand new show. And it's a little bit different than our other show, OpenCV Live, in that instead of inviting guests on to do a presentation, this show is much more conversational. We're going to learn about their successes, their failures, and gain valuable insights from innovators in technology. And for our first episode, we have a very special guest. Kwabena Agyeman is the CEO of OpenMV and a co-founder there. They just launched a Kickstarter campaign for 2 new camera modules with AI power built in. Please enjoy this conversation with OpenCV CEO Dr. Satya Mallick and OpenMV CEO Kwabena Agyeman.
Great to see you, Satya. Did I get your name right?
Yeah, close enough. I mean, I don't care about the pronunciation of my name as much because even in India, different places, in different places, my name is pronounced slightly differently.
Yeah, so a little bit about me to the audience. I'm Kwabena. I run a company called OpenMV, and we do computer vision on microcontrollers. Basically what we've been doing for the last 10 years is more or less developing not OpenCV, but a image processing library for microcontrollers. And so, we're reaching out today to talk about some new stuff we have, which we'll go into later in this conversation. But more or less, there's some excitement on the front that really enables AI and ML on the edge. And so I wanted to bring these new things to the OpenCV audience. Before I get into that, though, I'd just like to talk a little bit about OpenCV, Satya. Can you tell me about how the project's going? You guys just ran, well, not just ran, but last year, I think, you guys were, or 2 years ago, you guys were running a fundraiser and have, been working hard to build out the organization and such. What's happening?
OpenCV is the biggest computer vision library in the world, and it has been around for 25 years. This is the 25th year of OpenCV. And this is the largest computer vision library in the world, largest open source computer vision library in the world, with over 2,500 different algorithms implemented in it. And now we are just a couple of months away from the launch of OpenCV 5. So OpenCV 5 is basically a rework of the OpenCV library. We are doing a lot of optimizations, cleaning up the library because, a lot of over 25 years, it has accumulated so many different algorithms, some of which may not be anymore the state of the art. And so we are moving them out. We are cleaning up the library. We are speeding it up for different platforms like ARM, Qualcomm, etc. And so a lot of work is going on, and we did do a fundraiser last year. It was an Indiegogo campaign and we raised about $92,000 through that campaign. But we also have sponsors who generously, companies like Intel, Qualcomm, ARM, RunPod. They are our gold members, and they generously donate to the library. And there are several other companies which are silver members as well as bronze members, right? So that's how it is funded. I just also want to mention a little bit about myself. Other than OpenCV, I also run a computer vision and AI consulting firm called Big Vision LLC. So I get to see a lot of things in the computer vision industry, not just from the perspective of a nonprofit, but also from the perspective, what are people building using these technologies, right?
Gotcha. Yeah, and on that commercial side of things, I wanted to ask, what are the problems and things that people are really trying to do right now? Is everything still focused on I know there's a lot of in the cloud activity and such, but do you see, on-device situations being a big deal right now? What are the problems people are wanting to tackle with OpenCV lately? What are the big growth trends?
Yeah, so one of the things I've seen in computer vision in general, right? So right now we are seeing in AI, if you think people are focusing a lot on LLMs, etc. But if you and that's great for when you want to do knowledge work, right? A person sitting in front of a computer, they want to do certain kinds of tasks. These LLMs work great. But the next big revolution which is happening in AI. It's the computer vision revolution. And the reason is that when AI interacts with the real world, right? So currently AI is interacting with a human, right? We are just typing through a computer, right? But imagine when it goes to the real world, when AI interacts with the real world, it needs to perceive the real world, right? For example, in Tesla full self-driving, it is all vision based. The reason is that whenever AI wants to interact with the real world, the perception part is done through computer vision. And that is a trend that is going to explode in the next 5 years. We are already seeing it grow very fast, but that trend is going to explode. For example, if you look at Tesla self-driving, right? It is all cameras interacting with the real world. Now think about robotics. It's all, all the perception part is done using computer vision. Even for static robots, if you want to grasp something, they need to understand what is the orientation of this object that they are trying to grasp. So they need to estimate the pose before they can grasp. That's all done using cameras. Medical diagnostics, it is all camera based, right? A lot of it is camera based because people want to do MRIs, CT scans, all of these things, right? They want to automatically analyze it. That's all camera based. Now think about AR, VR, Apple Vision Pro. It's called Apple Vision Pro. It is computer vision, right? Because they have 12 cameras. Some of them are looking outside, trying to determine your head pose. Some of them are looking inside your eyes, trying to determine where your eyes are looking, right? The OS is also called Vision OS, right? It is a computer vision device, essentially. So you can think wherever there is this massive revolution going to happen, which is already underway, where AI interacts with the real world, and there cameras of all kinds. Some of the processing will be done on the cloud, but a lot of the processing would be done on embedded devices. And there are different ranges of cameras, right? Some need to have very heavy duty, hardware processing. Some don't, right? So it's a whole collection of cameras and computer vision systems that need to be deployed on the edge.
Yeah. And I know that there's a big thing taking off, which is the new vision transformers, but are we seeing those only in the cloud right now, or are people able to bring those on edge? I think they're too large to go on edge really right now.
They are too large. They are too large to go on the edge. The good news is that they're not always necessary, right? There are so many different applications. If you master 3 computer vision tricks, right? One is image classification, object detection, and segmentation, and you build high quality models for that. You quantize those models, you make them small, you distill the knowledge from larger models if necessary, but you can create small models that solve the specific problem, right? The thing, when you want to solve generic problems, then you need a lot of heavy duty compute. But if you want to solve specific problems, which is like the vast majority of cases, even now, right? Where you don't want to build something general purpose, you want to solve something very specific, then you can get away with a lot of, very standard, ResNet 50 would go a long way to solve many problems.
Yeah, yeah. Well, segueing there a little bit, that's where I wanted to introduce what OpenMV has that's new and that's applicable for everyone who's using OpenCV and who's playing with models. I'd like to introduce to you the new OpenMV Cam AE3. It is a new, so the OpenMV Cam is a product where we have MicroPython. So, similar to your desktop Python running on board a microcontroller. And historically, we've never had support for running neural network models with any acceleration. We've been able to do it with the CPU.
Wow.
But now we're able to actually leverage new neural processing units that are coming out and are running on board these microcontrollers. And so this little guy I'm holding in front of you, that chip in the center, that's 6 by 7 millimeters. And it has a 200 gigaops neural network accelerator on board. This means that it's able to actually run neural network models on the edge at pretty fast speed. So 200 gigaops, it translates into a YOLO V5 model, for example, 224 by 224, running at 30 frames a second, more or less. on a device that draws about 60 milliamperes of power at 5
Wow.
volts. And so that's about 0.25 watts of power. In comparison, our previous camera, the OpenMV Cam H7 and RT1062, which were just pure microcontroller-based solutions, those got about 0.6 frames a second on the
Wow.
same model, and they drew about 170 milliamperes or so. So we're
That's
looking at
almost like 50x.
more than that, more than that. It is a 100x, sorry, it's like a 90x performance increase,
Right.
basically, and then a 3x power consumption drop. And
Wow.
the total is something on the order of 200 to 300 times better.
Wow.
And we're excited to introduce this technology because when you're looking at a not just one order of magnitude, but a 2 order of magnitude speed up,
Yep.
this means that we're going to be able to unlock a ridiculous number of use cases for folks that were previously impossible. So let me talk about the features on board this guy just to get people excited. First, the camera is a global shutter, 1 megapixel, able to run at color global shutter, by the way. So default color global shutter. We're starting with the actual machine vision technology you want. And that's going to be able to run at about 30 FPS full res, and then 120 frames a second in VGA, and 240 frames a second in QVGA. We've got an 8x8 time of flight sensor on the front too. And
Oh,
so
wow.
that's the distance issue. We get tons of people, always asking us on our forums, hey, can you tell me what the distance an object is away from the camera? And it's a trick question because cameras don't measure distance, but
Right.
we have something to solve that. But furthermore, Wi-Fi and Bluetooth on board, along with 32 megabytes to store models. And so this means you have enough space to put a standard YOLO Nano or YOLO small model on board. And you can fit, maybe 3 to 4 small models or 2 large ones.
Right.
That can be expanded as necessary based on our build style too. So we can go up to 512 megabytes. If we wanted to switch out chips, they get a little bit expensive, so we're going to start with 32 by default, but then that can be changed.
Yeah.
And then also there's a microphone on board, and then an accelerometer and gyroscope centered in the camera.
Nice.
And so this whole thing is going to be your AI powerhouse for a target price of around $80, actually.
That's awesome. And the power consumption is also such that it can be very power efficient, run off batteries and such, right?
Yeah. So actually, case in point, at 60 milliampere draw, if you've got about, if you have 2 particularly beefy AA batteries, for example, you're looking at multiple days of battery life running on board that, kind of almost up to a week with just 2 AA batteries, full power. So you can have this thing just running, not even going to sleep because current consumption is so low. But then in sleep mode, we can actually get that down to about 500 microamperes at 5 volts. We want to get that lower, where our target was actually 50. 500 is a little bit higher than where we want to be, but as we have software maturity, we'll be able to work that down. The chip we're using has a lot of features on board that let you play with exactly how much power it draws.
Right.
But when you talk about like 500 microamperes, then you're looking at like those batteries lasting for years, actually.
Right.
And so being able to go up and down between low power and high power mode means you can actually have a battery powered AI, system that has connectivity that can be deployed anywhere and provide analytics, for example, or any type of sensing you want. Of course, I imagine some people are going to want to make a little pin that goes on your shirt and transmit data, but that's not really where we see this thing being used particularly. It's kind of perfect for when you need to deploy a camera into a remote location. Not necessarily remote, but a location where you don't have access to power, which is repeatedly what we see from a lot of customers is they love what you can do with computer vision, with new models. But then when you want to go deploy those, you have the challenge of people want battery-powered stuff versus it being plugged into a wall.
Can I tell you one application that I've discussed, but I've actually, it's a very good business opportunity for people who may be listening. So there are a lot of meters, right? Like physical meters in the world measuring different things, right? And let's say the gas meter or they are not digital, old ones, right, at old houses, or even the water meter, those are not digital. So somebody comes and in many parts of the world, I don't know whether this is true about US, but many parts of the world, you will see that somebody actually comes and occasionally goes and checks what the meter reading is, and then you get billed for that. And it's very difficult to actually go and change these meters, right? Because they are very expensive to convert it to digital. On the other hand, usually they are in a box kind of a setting, and you can actually put a camera in the meter. The camera would wake up every day or maybe even every month, take a snapshot, do the analysis, and send it. And because you have the connectivity, right, it can send it the data over. So now you have like a kind of digital meter that is monitoring these things, and you're able to achieve that with much less. $80 is nothing, right?
Yeah. We actually have some customers doing that who are putting these cameras in industrial plants.
Yeah.
They don't actually use the ML piece that we can run on board. So we do have a very low-end computer vision light. Well, I'm not say low-end, but we have parts of OpenCV that have been ported to the OpenMV cam. So something like line detection, for example, using a hue transform, that can be used to easily read a digital meter. There's the fine line segments using the LSD algorithm, for example, that OpenCV has. And so we have that running on board our system too. And that provides a very trivial way to get line segments, then which you could use to build a very easy classifier on trying to see what a gauge looks like. And so that's doable on board. Or you can just brute force it with doing image classification, which is
like a small OCR model, right? Because OCR model can also read the meter reading. That could also probably work.
Yeah, that might save some time instead of like doing manual computer vision stuff. It's weird because it's like, we have so many algorithms we developed for the yesteryear, and pretty much you can solve everything now just using models on board.
Right.
But also it makes sense though, because when you think about the performance of these AI accelerators compared to a CPU, it actually is faster to do things via the AI accelerator than try to use the CPU. An example, so this feature is also, by the way, two different things. First, it actually has two cores on board. So it has a low power core and a high power core. This allows you to actually do multi-processor applications in Python. We use something called the UAsync IO module. So you do, it's kind of like the async IO on Python, pretty much exactly the same. So you do coroutines. And what you can do though is you can actually spawn a second processor core to run coroutines while the first one is also doing something. And that second processor core could have multiple coroutines on it that are all sharing it. And then both processor cores also feature neural network accelerators private for them. So this means that you can have AI and ML running on like the microphone or accelerometer in a low power state. And in this mode, you'd be drawing like 30 milliamperes or less. And that could like be wake up on audio keyword detection or motion. And then you can start running the camera after that and doing like AI on the camera and so on and so forth. By having this low power processor core here, it really opens up doing these like multimodal applications where you type in computer vision with like the accelerometer or microphone information to be able to build something that can last in a low power state and then wake up prime to record data and so on and so forth. Yes. And then also we have a higher end system based on something called the OpenMV cam. This is OpenMV cam N6. And so this is based on the STM32N6 from ST. And so this is a new processor. So the STM32 series of microcontrollers is a pretty popular line of MCUs. The N6 is the latest, and so it features a 600 gigaop neural network accelerator, so 3x the performance of this, also 3x the power draw, but it's got stuff like H.264 in hardware, so one of the first microcontrollers that has H.264. It's also got an ISP in hardware, an image signal processor. So this means that it can debayer a regular color camera. So you can have MIPI CSI bus, that's receiving your color image. It can do the image debayering on board.
And the video encoding also because of the...
Yes.
Yeah,
Yes.
that's very powerful. I mean, people don't realize how important it is that the encoding be done on the device. The network becomes very free, right?
Oh yeah, no, absolutely. But it's crazy because those used to be only you can only get those on higher end multiple higher end Linux based systems, and so having a bare metal microcontroller having access to that is crazy.
Yeah,
Because when I say it has an ISP, this means that it can be receiving like up to 5 megapixel camera,
yeah,
right? And then it can be running that into the AI accelerator, and it could be encoding that as H.264. And then
wow,
we've got a gigabit Ethernet PHY on board. So
right,
this thing actually supports 10, 100, and 1,000 Ethernet. And so this means you can have a PoE-based camera, for example, that is streaming H.264 encoded video with AI detections. And
right.
it has instant on boot. One of the benefits of having a microcontroller is that the boot time is instant. The second it turns on, it's running your application. There's no middleware or anything else going on there. And then you have the ability to go in and out of low power state kind of on demand, which is where you get insane battery life, actually.
Right, right, right. That's
Um,
awesome. That's remarkable that you could do so many things in that little device.
yeah, yeah. And then just to finish up on the features of this guy, unlike the smaller one, though, it comes with an SD card, so that allow you to have whatever storage you want on board. And that's a UHS-1 speed, so that's up to 100 megabytes a second to the SD card. Similarly, we've got a microphone on the back also for audio detection, and then an accelerometer gyroscope behind the camera that's centered. So you can kind of figure out what, how motion is happening. And then we have USB high speed on both of them, so 480 megabits a second. And this guy actually has battery charging on board. And then I guess the final feature is this guy has, so one interesting thing to note on where, if you know anything about microcontrollers, where these things have gone. These latest MCUs, for example, this guy in this 6x7 millimeter package, it's got 13 megabytes of RAM on chip, which is actually very obscene compared to microcontrollers that you could buy today even.
Right.
And that RAM is clocked at 400 megahertz with a 64-bit bus, so it's actually about 3 gigabytes a second. So that's equivalent to DDR4 speeds, actually. So
Right.
as
Wow.
long as your model and all the data structures and everything you need to touch are inside of the chip, it is basically putting out numbers that are as fast as a DDR4 based system. Same thing for the N6. It's got more RAM externally though, that's clocked at about DDR2 speeds, so 800 megabytes a second. But it's just crazy that these are microcontrollers. These are not a Linux-based application processor. And yet this little guy probably has the specs to run Windows XP or even better than an old 2000 era computer, more or less.
Right.
And it's just, this is a dedicated system, though, to do one task in life, which is to sense, plan, and act on whatever you want.
Right. And for people who may be not very familiar with microcontrollers, etc., how do you program the devices?
Yeah, yeah. So actually, would you like to do a live demo and I can kind of show you?
Yeah, that would be lovely.
Okay, let me get into it. So I'll show off the OpenMV N6 first. Well, and then actually let me do the AE3 first, since that one's really, really tiny. So we've still got just a preface. We're still tuning the camera sensor. It's kind of at raw Bayer level right now.
Yeah.
So because we have like a ton of things to do in the company, and not a lot of manpower. So we're getting it done as we can. The goal right now is to focus on shipping units and then work on the software final touches later. But here we go. So let me see if I can share my screen real quick. Okay, so the way you actually program the OpenMV is we have a IDE called OpenMV IDE. And so this lets you write MicroPython code. So you have a Python script on the left-hand side, and then the ability to see what the Python script is doing. And so the kind of way it works is that you connect to the camera, and that starts transmitting data back and forth. And then based on that, looks like hold on, I'm running the wrong script here. Based on that, you can run the script and see what things look like. So
Oh, nice.
here's an example of me running.
Yeah.
And so you can just see though how much get up and go that has, right? I just
Right.
connected the camera, plugged in the script, and now I am detecting myself there. And so the camera system is doing about 17 frames a second while it's streaming to the computer.
Yeah.
That though is based on the system load. So if I stop it and then disable the frame buffer so it doesn't have to actually stream to the PC, it's
Yeah.
closer to about 28 frames a second right now here,
Nice.
if we look on the bottom. And so
Right.
once we spend some more time optimizing things, there's a lot of fruit to pick still on how fast we can make this.
Mm-hmm.
We should hopefully be able to get that probably up to above 30, maybe potentially 40 frames a second. And this is the YOLO V, and this is a YOLO V5 224 by 224 model.
That's
It's
awesome.
it's trained on the FLIR person detection data set, thermal. It's like a thermal, mixed thermal, and color data set. So
Right.
not particularly amazing for being close by, but this is generically any model though. We can run on board at this speed. And so I just wanted to talk a little bit about the code and what this looks like. So this script here, this is everything for running this model we just saw.
Right.
What we've done is we have an advanced camera driver framework. So all of the details on debayering the camera, getting the image in, and doing all the buffering, we handle for you.
Yeah.
So you just kind of invoke these Python commands that say, set the format to like RGB 565, which is 5 bits per pixel, set it to VGA. You can change the camera sensor frame rate. So this can go from 30 frames a second to 240, depending on the resolution. And then after that, you call snapshot. And so what's actually happening here is we have a whole triple buffer frame buffer architecture built on the system. So it's going to allocate 2 back buffers, for example, on where the image is coming in from the camera, and interrupts handle that, and that's kind of accumulated in. And then your Python code at the high level, at the user level, you're just calling snapshot, which returns an image object. So it's similar to kind of how OpenCV is just getting frames. You don't really have to think about all the details on how camera images, actually make it onto into your code base. We kind of make that easy for you and such. And then we have our own ML framework actually that we've built on board, where you just load a model. And so that model can be stored on disk, for example. And there's 2 ways this works actually. You can either have it on disk so we have a FAT file system, and then we have something called that appears in the computer. And then we also have something called ROMFS, which is a linear file system that is memory mapped into the microcontroller's memory region. The way to think about that is like, imagine you're doing an AI or ML application and you compile your model into your final C file, your executable image. This isn't something you need to think about on the desktop per se when you have infinite memory, but when you're on a system that has less RAM, what we try to do is we want to actually execute the model in place so that we don't have to load it into memory. And so this is superpowers. Basically, the model itself can be stored on an external flash that is attached to the processor. And so the processor will execute that model in place. And then we have a memory region allocated to where the inference happens, like the tensor arena. And so that tensor arena will be on board in RAM, but all the weights of the model will be stored in flash.
Right.
So this little innovation there allows us then to take that 16 megabytes or so I mentioned of the flash drive we're using, and you can have the model in that, and then the 13 megabytes on board is where you actually have the weights and everything and the inference going on. So that little feature allows you to get really big models, though, on board these small microcontrollers. Anyway, we wrap it up, though. There's a lot of C code happening in the back end that someone would have to deal with, and so all of that's hidden. And we just do predict, and then we have a callback to post-process. And the best thing about this callbacks is we actually have NumPy running on board. So the way we do things is we have, when we were trying to build up this system, there were an infinite number of models to support. So it was challenging to know what should we do from the model perspective on how many model types should we support and et cetera. How do we write C code for them? And so instead we chose to do something where we have all the post-processing done in NumPy on the back end of the system. And just for the readers here, I can give an example of what that looks like. So when we're post-processing it, basically we're able to kind of take the out, like this post-processing method that you see right here, this guy, it's only this much code. So what is this? Like 40 lines of code to post-process a YOLO V5 model. And so by having NumPy on board the system, that, you know, for everyone who's familiar with that, this lets you get you basically give the predict call a list of tensors, which are, you know, your arrays, and then you return a list of tensors. And so each of those tensors, sorry, someone gave me a call. Let me put my phone on mute. Each of those tensors basically can be post-processed by NumPy and handled on board, and then we're able to draw the detections. So it's a very innovative way of handling computing on a microcontroller unit. Normally folks do everything in C, but we wanted to provide a Python-esque way of making this possible for users to do what they need to do and be flexible about it, to be able to quickly change scripts and run things on board.
Nice.
And I assume you're quite familiar with NumPy and uses,
Yes.
right? Yeah.
Yes, of course. Yeah.
Okay, and then before we wrap up, I wanted to give a demonstration of the thermal imaging performance of the OpenMV Cam N6 actually. And so this is a fun model also, which is to play around with thermal imaging sensors. And so this is called the FLIR boson. This is a thermal camera that sees 640 by 512. And so it gives you a lot of superpowers. In particular for industrial applications, it's really, really useful for being able to see what's going on and what's happening in the real world.
Yeah, it's also funny. The seat you are sitting on is warm.
Yeah,
Right.
you can see my butt.
That's right. So this is real.
Yeah, no, it's real. And this is the kind of performance that we're going to be giving to folks who are interested in the system. So note that we're only doing 12 FPS right here because I'm recoloring it as the iron bow. We have a lot to optimize, as I said. So it actually does 30 FPS once I remove that call.
Wow.
And you can see the benefit of having Python on board a microcontroller right then and there, because I just changed the whole program behavior, right?
Yeah.
And I was able to stop the script, change it, and then run a new script pretty much instantly.
Yeah.
And then if you disable the load of it having to stream back to the computer, the performance is more like, yeah, 40, let's see, about 40 frames a second. Probably you can get it a little bit higher, maybe about 50 frames a second when it's running the YOLO model. And so that's kind of the difference between these two systems, is that depending on what model you're going to be running, you're going to see the N6 potentially being on the order of 2 to 3x faster than the smaller model, than the smaller system. But whatever the case, these are the first embedded microcontroller systems that really give you the ability to run general purpose models like YOLO, and also human body pose, facial landmarks, image segmentation, you name it.
Right.
A low power system that can be composed with MicroPython to do whatever you want, and then deployed in a real environment, drawing very little power. The N6 in particular, the camera we're demoing right now, this only draws about 3x the power of the smaller one, but we're still under 1 watt of power consumption, which is incredible. And then also it has a low power mode where it can go down to about 1 milliamp of power consumption on demand. And that's, what is that? That's like 5 milliwatts of power, basically. And so that means that when it's in that low power mode, you're looking at, again, you know, years of battery life. Well, it's waiting for something to wake it up. So you could have this connected to like a motion detection sensor, like a PIR sensor. The thing then could wake up when it sees motion, start recording video, capture an image, transmit that somewhere, whatever you want to do.
Right.
Yeah. I mean, like, what applications, before we go, that could you solve with this, Satya? Like, what is new that previously was not doable?
Yeah, so I mean, I see a lot of applications where low power is key, right? Where you do not need to have power connectivity, which is always, always a problem when you want to get it. Let's say on a mobile robot, you want to get it, right? You can easily do this thing. And the processor is so powerful right now. The demo that I just saw, right? It is mind blowing, especially with thermal also. And so these things are mind blowing. The kinds of applications now you can build, it's quite fascinating, right? Object detector running on it at 30 frames a second. That itself has so many different applications you can think about. Like I said, that any if you think about any computer vision application, 80% of them, they can be classified into three things, right? Image classification, object detection, and segmentation. If you're able to do that on the device, these are very powerful. And I'm guessing that classification would be many, a few hundred frames a second, because it will be determined by the number of frames the camera can run at, right? For classification networks, which itself is great. Yeah.
Yeah, absolutely. Just a number. We have actually, there's one more sensor that I want to show you guys that's actually very, very interesting because you haven't seen it before.
Yeah.
It'll blow your mind. But no, I wanted to mention regarding the classification networks. No, so for the OpenMV, so originally we could only run classification networks on our microcontroller cameras. So we could do like at best maybe 20 frames a second doing image classification where we're just giving you a label. And that was still amazing. Like, hey, we could do, a microcontroller typically had about 1 gigaop of compute. So again, we're going from like 1 gigaop to 200 and 600. So huge jumps, multiple orders of magnitude. That's why this is so exciting. But we could just do image classification. That was it. Now with these new systems, we're seeing image classification numbers that are like below 1 millisecond. And so literally you can do like, there's a model called FOMO from a company called Edge Impulse that does centroid detection on an image. And that one runs at like 0.6 milliseconds. And so we're able to actually hit, for the OpenMV Cam AE3, it can output about 240 frames a second at its lowest resolution.
Yeah.
And we can actually run the FOMO model, for example, at speed on that.
Wow.
I can actually demo that. Let me go back to Sharon, since these are the now oddities of this talk, and I think people can kick out of it. So let's go back to it. Don't want to go on for too long, but let's check it out. Okay, so this is a very interesting camera called the Gen X 320. So this is called an event camera. So I don't have this running on the N6 right now. It's running on one of our older systems. It does work on the N6 though. But I wanted to just introduce it to people because this is some event cameras are a very interesting sensor that only see motion.
Right.
The benefit here, let me just turn the contrast up.
Super fast.
Yeah, no, they can be set to any frame rate. So let me see. Build contrast, let's say 64. Okay, cool. So this is an event camera, and so it runs at 50 FPS by default, but you can also say like, I want to set the frame rate to, I don't know, like 200 frames a second, right? And then it'll, boom, go up to 150, and if I disable the load of the computer sending images, it's 172 with the current driver. Anyway, so very, very fast frame rate. But the trick is they only see motion differences. And so like right now it's peeking and seeing my screen out of the field there. That's why that's flashing, because it sees my computer monitor. Yeah. But if I were to point it at, something static that's not moving, it's not going to see anything. Yeah. There it sees my fan spinning. It's like, anyway, the benefit though is you see like once you have no motion, it sees nothing. And then anything that moves appears in the field of view. These are very interesting cameras because with them, you can do really, really fast object counting. So, there's a lot of problems where you want to do like process control and want to be able to like see objects in the real world. Right. Like imagine you have your computer vision system deployed in a plant or something like that, and you need to count falling objects or like Skittles moving on a conveyor belt. All of a sudden, this really solves that application trivially because each pixel is a convex hull now of motion. It gives you like kind of like a LiDAR scan to work with from a camera. And so we're excited to see what people do with this when you couple it with the strong AI and ML.
Right.
Now you're going to be able to solve problems that were previously harder, and you need more training data much more easily. Obvious case in point here is that the image pixels are really just a grayscale color. Like right now I'm recoloring it with this color palette, but if I were to turn that off, this is fundamentally what the image looks like. And so there's just a lot less information you have to work with. But that also means it makes it so you can just build an AI model that's focusing on just what's important.
Right.
So this is the event camera. Anyway, my main goal showing this off is just to let people know this is a thing that is available. Note that you can do just regular, color tracking on this. You don't even need to use ML, for example, to see where an object is.
Right.
I just do color tracking. It's an easy way, shape, and form to track me around in the field of view.
Interesting.
And then before we go, it's probably going to be hard for me to demo the AE3 image data set. Got only a little bit of time left. So let's see if I can do the demo successfully. Okay. All right, so this is the FOMO model. It's probably gonna, okay. Let me see if I got the script ready to go on this. Hold on. I didn't have this one prepared. Nope, that's not it. Nope. Okay, I don't think I've built the demo of this particular model on live. But no, just wanted to say though that, the AE3, for example, if I were to go to its lowest mode, I could show that we're actually, we can say, for example, 240, I think. Yeah, so you can see on the frame counter right there, it actually does achieve 240 frames a second at QVGA resolution. And so you can kind of actually see the flickering lights in the image.
Yeah.
It's going so fast that it sees my lights turning off and on actually from the AC power. And so this kind of unlocks like some really interesting applications for the high-speed computer vision. And then if you switch to 120, if you update the resolution to VGA, of course, you can get it to 120 frames a second. And then we actually support all the way up to HD. And that can come through also. And so, yeah, it's a very fun sensor. We still got a lot of work to do on the ISP to improve it and make the image quality better, but just right out of the box, currently it's decent and usable.
Yeah, that was awesome. I mean, to be honest, I'm floored. There's a lot of new stuff and things are so fast.
Thank you. Yeah, we're excited what people are going to be able to do. And so my call to action is, if you are excited about this demo, we're running our Kickstarter for the OpenMV N6 and AE3 right now. And so please back us on Kickstarter and help make our launch of these new products successful.
So once again, what was the Kickstarter price for both of them?
So we're looking at a target price of around $80 for the OpenMV AE3. Might be a little bit higher than 80, but hopefully we're targeting 80. And then we're also looking at a price of about $120 for the OpenMV N6. So both of them are affordable, and that's the all-in price. And so the OpenMV AE3 will actually come with a nice case like this.
Oh, wow.
So it'll be with a nice injection molded case, blue with some wording on the back. And then the N6 will come with the camera and a global shutter sensor all in one package. So kind of similar to looking like this. It'll come as a base unit. And so we've got shields and accessories for the N6, for example. So you're going to have the option to buy a PoE Ethernet shield for it. We would like to offer an audio shield, but that's still under R&D, so that'll happen or not. And then we're actually going to have cellular shields for both of them that'll launch later this year. So the AE3 will have a cellular package that gives you the ability to do GPS or LTE connectivity. That way you have a quad antenna system, so Wi-Fi, Bluetooth, GPS, and LTE, and that'll work. And we'll have two different variants of that, one for the N6 and one for the OpenMV AE3. And then finally, we're also working on 3D printable cases for both of them. We're going to have those available for people to download. And then an IP65 rated case for both of them that'll allow you to, add your own batteries and then deploy that into the real world.
That's awesome. That's awesome.
Yeah, thank you for listening.
I mean, I really encourage people who are interested in embedded computer vision to check it out. Even when people are not interested in embedded computer vision, you'd be surprised what these devices can do, and it can open up your, the field of view, right? What are the various things that you can do? And I encourage people to go and check this out. It's an awesome piece of hardware. Because we did not talk about it before. I'm very impressed by what you have been able to build, right? And the IDE, does it come with? Is it free? Does it come with the when you buy a unit, or how does it work?
Yes. So the IDE is 100% free. It's actually open source. You can hack it if you want to, and we've totally actually been hacked and cloned in China. That's for sure.
Right.
The hardware is pseudo open source. So we have Altium files available online that have a viewer. So you're able to click on any trace on the board, figure out where any signal goes. We make that possible and easy to do so that as an engineer, if you have a problem on trying to figure out why something doesn't do what it needs to do, or you want to get in-depth knowledge, we make all that available. The hardware files are not, though, available for download. We do want you to buy boards. That's how we function as a company. But we try to make it easy from the engineer's side of things. And then as for the firmware, that's all available on GitHub. And so you can compile the firmware, flash new variants, and modify and change the behavior of the system as you please. Of course, this is kind of equivalent to Linux kernel level hacking at the complexity of these microcontrollers. So we do have a lot of bootstrap code that makes it easy to work with, but at the same time, it's going to be, if you want to go play with the firmware and see, you should have some understanding of how to do these things. Satya, thanks for making time to talk with me today. This was awesome. I hope you could see what we're doing, and I hope that this conversation brings some value to the OpenCV community, and really expands what people are going to be able to do with AI and ML models in the real world.
Yeah, I'm really glad we had this conversation, and this is awesome stuff that you have built. I really believe that a lot of people in our community will be able to benefit from what you're building, and keep up the good work. We had spoken a few years back, I think, and things were very exciting even at that. But now it is like it is just mind blowing what you have been able to achieve with these new devices. So I'm very excited. I'm personally going to support the campaign as well. So looking forward to it.
Thank you. Thank you.
Well, we hope you enjoyed that conversation with OpenMV founder Kwabena, and we hope that you'll support their Kickstarter campaign. Go check that out on Kickstarter.com. And we hope that you watch the next episode of OpenCV in Conversation. Take care of yourselves out there. Take care of somebody else if you can, and have a great day wherever you may be.